Yeah, welcome to my YouTube channel. In this video, I'm going to be solving this equation which says n raised to power 32 is equal to 2 raised to power n. Now, there's a condition here. They said when n is an element of a natural number. This capital letter N is a natural number. Quickly, what's a natural number? A natural number is a positive integer. For example, 2, 3, 5, 7, and the likes. Okay, now how do we start solving this? I am going to start off by eliminating the real number from the variable. What I have here is n, but I also have n here. Now, I want to try as much as possible to remove this n from here and also remove 32 from here so that I will have the variable on one side and I'll have the real numbers on the other side. If I want to get rid of this raised to power n here, I will have to apply the nth root to both sides. Nth root, that's 1 over n. Okay, so what I'm going to do here is to write it like this: n raised to power 32 times the nth root, so 1 over n. This is equal to 2 raised to power n, again, times what? The nth root. When I say nth root, see, this is what I mean when I say nth root. One of the laws of indices, this can be expressed as a raised to power what? 1 over n. So for me to be multiplying the powers by 1 over n is the same thing as applying the nth root to both sides of the equation. Okay, so this n will cancel this n, and I have n raised to power 32. You can multiply this, you are going to have over n is equal to 2 because the n here has been cancelled out. So one part of the job has been done. I need to remove this 32 from here, this power of 32. What can I do? The same thing I did when I was trying to get rid of the power of n. I'm also going to apply the 32nd root to both sides. So what does that mean? I'm going to multiply their powers by 1 over 32 so that I can get rid of 32 from here. So watch this now. 1 over 32 here, and again 1 over 32. Okay, so 32 cancels 32, and then you have n raised to power what? 1 over n. 1 over n is equal to 2 raised to the power what? 1 over 32. But I cannot conclude and say n is equal to 2 or n is equal to 32. If I need to equate n, then the basis and the root must match, but they don't match. So I will have to manipulate my way into making the base and the root match so that I can equate n and say, okay, n is equal to either 7 or whatever is going to be when we get the value of n. So here's what I'm going to do. I'm going to try as much as possible to manipulate the base here and the root here. So I will do that by multiplying by 2 over 2. Notice this 2 would, this 2 is the power. It will be applied to the base, and this root here would be used to multiply this root here. So there will now be a change in the base and a change in the root. If we do that, say 2, 3 times, we could have a match of the base and the root. So once we have the same number in the base and the root, then of course we can just equate the value of n on both sides. Okay, so if I'm to do that, this will be n raised by 1 over n is equal to 2. See, this 2 would be applied to the base of 2. So I'm going to write it like this: 2 times 1 over 32 times 2. Nothing has changed. And again, let me just quickly tell you why I multiplied by 2 over 2. You might be wondering, am I not changing the value? No, I've not, because I can cancel out and it will have no effect on 1 over 32. So nothing has changed. The fact that I am multiplying the exponent by 2 over 2 doesn't change anything. So see what I have now. I just distributed it and I have it here. So power is applied to the base and then the root is applied to the root, so that I would have a change in the base and in the root. So I have n raised by 1 over n is equal to, what is 2 raised to the power of 2? That's 4. and then 1 over. What is 32 times 2? That's 64. Okay, we still don't have a match. The numbers still don't match. This is 4, this is 64. So I'm going to try the same thing again, and let's keep going like that. So n raised to the power 1 over n is equal to 4 raised to the power 1 over 64 times 2 over 2. Same thing, this power will be applied to the base of 4, while this 2 here, the root, will be applied to 64. Okay, now let's quickly do that. So I'm going to have n raised to the power 1 over n is equal to 4 raised to the power 2 times 1 over 64 times 2. Okay? All right. So that will be n raised to the power 1 over n is equal to, what is 4 raised to the power 2? That is 16. Then 1 over. What is 64 times 2? That's 128. We are still going to try one more time. Perhaps it might just work this time around. So again, do the same thing. N raised to the power 1 over n is equal to 16 raised to the power of 1 over 28 times 2 over 2. So let's repeat the same process. I have n raised to the power 1 over n is equal to 16. Now, let me come back here. This 2 will be applied to the 16, while this 2 will be used to multiply the root here, 128, just like I did before. So I'm going to have raised to the power 2, then times 1 over 128 times 2. Very good. So n raised to the power 1 over n is equal to, what is 16 raised to the power of 2? Let's quickly do that here. If we are doing this without a calculator, 6 times 6 is 36, right? 6 carry 3. 6 times 1 is 6, plus 3 is 9. 1 times 6 is 6. 1 times 1 is 1. So when you add, you have 6 here. 9 plus 6 is 15, right? 5 carry 1, and that is, so we have 256. Okay. Then 1 over. What is 128 times 2? That is 256. Wow. So can you see that the base here and the root match? So see, you can compare in every way, at the base level, even at the root level, we can compare. So we conclude by saying that therefore the value of n is equal to 256. If you enjoyed this video, kindly like, share with your friends and family, and don't forget to subscribe to this channel for more content like this. I'll see you in the next video. Bye for now.